Hello students, today we will discuss about difference between interference and diffraction of light. We have mentioned a difference, although there will be comparison between interference and diffraction of light. So point number one, interference is due to superposition of light waves coming from two different coherent sources. So coherent means if you have two light sources having same amplitude, same wavelength or frequency and constant phase difference, then the two wavelengths will be considered as coherent light sources or coherent sources. When they will superpose with each other, this will give you interference pattern. Whereas for diffraction, the interference of secondary wavelength coming from different point of same wavefronts. In here also there will be superposition, there will be interaction between wavelengths of secondary light sources. So how to get secondary light sources? So secondary light sources is if you have a slit of slit gap of D and the incident light wavelength is lambda. If they are comparable in the same order, then from primary wavefront the secondary wavelets will be produced. The superposition between secondary wavelets will give you diffraction pattern. Point number two. Interference fringes may be or may not be of same width. Diffraction fringes are never be of same width. Now, as the interference case is a symmetric case, so if the symmetricity is maintained, then the fringe width may be same. If there is some disturbance, they will deviate from this point. But in case of diffraction, fringe width never be same, because here we are not satisfying the condition of symmetricity in the system. Point number three. In interference pattern, all bright fringes are of same intensity. In diffraction pattern, the intensity of successive bright fringes goes on decreasing. So here the maximas, bright fringes or the constructive interference pattern, they will be of same intensity. Whereas for the diffraction, the intensities, the maximum intensities will decrease with that phase value. Point number four. Interference pattern of minima, intensity at minima is zero or very, very small. It's almost dark, and there will be good contrast between bright and dark fringes, maximas and minimas, constructive and destructive interference. Whereas the diffraction pattern, the intensity's minimum never be zero. So there will be very poor contrast between bright and dark fringes, maximas and minimas. Now in the next slide, just you will see a simple diagram that explaining the interference and diffraction. Left side of the screen, it shows the interference experiment, where we are trying to perform Young's double slit experiment, where we have a primary light source in this section, primary light source. So from primary light sources, it is exposed to two slits, and from these 2 points we are getting to coherent light sources. These coherent light sources will superpose with each other, they will interact with each other. So this zone, this brighter zone, the deep red zone, you have the interaction between two coherent light sources. So one can get the pattern something like this. So you can see a very bright maximas, and you will see the dark points, these are black. So the intensity distribution is shown like this. So along this axis we are plotting intensity I, and here we are plotting the angle. As the intensities are equal, you can see the peaks are also having equal height, and the minimas are also absolute dark, it is showing. Whereas in case of diffraction, this side you have the diffraction experiment. So in this experiment, the primary light source is exposed to a secondary, a slit. Now the slit with D This gap is t. It is comparable to wavelength of light. In this case, we have taken 662 nanometer. So the gap of the slit is around in this orbit. So the secondary wavefronts will produce. The secondary wavelets, now they will interact with each other, they will superpose with each other, and they will produce diffraction pattern. So the intensity distribution will look something like this. So at the center, intensity is maximum, so you have the highest speed. But then you also have the maximums, but the peaks are quite lesser in comparison to the central maximum.